Am I audible? Roshini, Akash, Vinita, Lahari, and Sumalata.
Yes, ma'am.
Have you gone through the before sessions? I told you to revise the finite state mission, right? Did you understood overall concept? So what is mean by finite state mission? Conceptual wise, just a theory wise, before we discussed lot of times what are the applications and uh, like how the FSM will work. We already discussed, right? So can you tell me what is mean by finite state mission and how does the finite state mission will be worked and what is the goal of FSM and what are the different models available in finite state mission? Quickly, fast. Today we will discuss theory for finite state mission. Tomorrow we will discuss on writing the designs and verifying the test bench. Okay. So Mealy mission, mode mission, both we will write the program. And also we will discuss different models, how to write in easy way. And also most preferable programming styles also we'll discuss. Okay. So fast, can you tell me if you are not answering, I need to explain everything from scratch again. I think we discussed before 1 or 2 times. Sumalata, can you tell me what is mean by FSM and how does it work and what are the applications?
These are, combinational finite state and sequential finite state machines. Mealy and more are there. The more FSM, the output is depends on only present state, and Mealy is present state and present input also. The output is depends on. Am I
Okay.
audible, Prashant?
Yes, yes.
Yeah.
And which one is mostly preferred, either Mealy or Moore?
More only.
Why?
Because it depends on present state. It might uh, not on present input, right? It is an advantage for us. If any combination feedback loop is there, means again some unpredictable output will be chances of unpredictable output, and that's a better. I mean, more is more preferable.
Okay. Okay. Others, can you tell me the applications of finite state mission? Why we prefer FSM?
State machines basically means they have multiple states, and in each state, a particular task is performed. It moves from one state to another state depending upon the logic. For example, like Sumalata told, in mode machine, the output depends only on the present state, but in Mealy machine, the output depends on the present state as well as the previous state output. And finite state machines can be simply found in like traffic light controller or vending machines. So depending on a particular logic, it moves from one state to another state. In each state, it performs a different task. And I'm not sure about this point, but if which is more advantageous, maybe it depends on in which application we are trying to use which model.
Okay.
But I'm not sure about that.
Okay. Any other answers from others? Akash, Vinita, Lahari, Manoj. Okay. So first of all, what is mean by finite state mission? So in the name itself, if you observe, it have n number of finite states. Okay, we can also call as it's a complex sequential logic circuit. What are the normal sequential logic circuits like registers, counters, flip-flops, latches? These all are normal sequential logic circuit. Okay, but if you go to some project level, we'll use multiple number of registers, like thousands of registers, thousands of counter logic, which are integrated with some combinational logic circuit. Alone sequential logic circuit we never use in any project, right? Sometimes we may need to use the arithmetic and logical unit, or some BCD decimal, or some LCD displays. These type of components are related to the combinational logic circuit. Okay, so combinational plus sequential logic circuit we need to use in any project level, any specification level. Okay, so finite state machine means, suppose if you are designing any circuit, if I give to design a traffic light controller. Okay, so you don't know anything about the finite state machine, you just learn about the sequential logic circuits, like you just learned about registers, counters, only this topic. Okay, you don't have any idea about finite state machine. Okay, so in that case, how you will design a traffic light controller? First you will understand what is the specification. So what are the inputs for traffic light controller? Majorly we'll have three number of outputs, right? We'll get the output as a red color, yellow color, and a green color. Input, we need to apply some clock signal or some reset signal or any control signal to control red, yellow, green. Like that, these type of signals will be there based on the truth table or based on excitation table or any state table. We'll be drawing a truth table. From that we write the expressions. From the expressions we'll write the circuit diagram, right? However, we designed a synchronous counter, synchronous counter. Have you gone through the session I shared for synchronous counter? We need to follow the steps. First, for synchronous counter, you need to check what type of counter it is, whether up counter or down counter. Whether it is a modular counter or normal counter. Suppose if it is a up counter, 0 to 7, it is counting. Then you need to, for synchronous counter, you need to write the truth tables. Okay, so what is the present state? What is the next state? If present state is 0, then next state will be 1. If next state or if present state is 1, next state will be 2. If present state is 2, next state will be 3. Like that, you need to draw the truth table for present state and the next state. From the truth table, you need to write the output expression. From the output expression, you will be getting a 3 output expressions. One is for a first flip-flop TA maximum, you will get a 1. TB you will get the output of TA. TC you will get a input of first flip-flop AND operation and second flip-flop AND operation. Okay, mostly we designed using a AND gate between last between last two flip-flops we kept a AND gate. Okay, so this is what we just do for designing a single counter logic. Okay, from starting steps, if you want to follow all steps, we need to follow in this format. Okay, but if you go to traffic light controller, same you need to do, like red, yellow, green. 3 outputs mean what are the inputs? We need to write according to the functionality for red, yellow, green. Okay, based on the enable signals we need to take, but it is a lot of process. Okay, so without doing all those things, we don't create a sequential logic circuit here. Okay, here we are going to divide this specification into some states. Okay, state 1, state 2, state 3. State 1, which operation it should do. State 2, which operation. State 3, which operation. Like that, here we are dividing the functionality in terms of states. Okay, we are not generating any truth table. We have the excited here in finite state machine, we'll have different truth table that is related to FSM. Okay, but particularly according to the specification, we never draw the truth table and logic expressions like that. Okay, so first we'll always divide it into the states S0, S1, S2, three number of states. Okay, so what S0, what operation it should do, what is the functionality? Basically, in most of the cases, S0 will be reset state only. What is mean by reset state? Reset means most of you think like it's a zero, it go to zero. Reset means a not zero, it's an initial state. Okay, initial state means suppose red, yellow, green traffic light controller is there. Okay, so what is the initial state for traffic light controller? Initial state, all will be in red. After that, it will come to the position like one side is red, remaining side yellow, and the other side green. If there are four signals, sometimes we have four directions also, right? X direction or Y, like the junctions will be there. Based on that, it will be dependent. Every design will be totally dependent on the specification, because sometimes in metropolitan cities will have good traffic lot of conditions will be there. Okay, it's, particularly specification for walking we have one direction, for signal crossing we have one type of indication will be there. So that totally depends on the design, traffic light design style. Okay, in normal villages or cities we don't have all these signals, okay, for crossing or just indicator. We don't have all these things, just we have red, yellow, green. Based on the signal we need to follow. Okay, so here it will be divided into the different state. First one will be always initial state. Initial state means what is the starting state. If you go with another example like ATM machine. ATM machine, everyone know, everyone are using ATM, right? Suppose first we'll go to the ATM machine, how it will be working. First, ATM machine means here we need to insert some card in the first state. We will press on some button, which is a start button. When we go to near ATM machine, it will show some regarding to that which bank it is, the details of that particular bank and logo, all these things will be shown, right? So that design is nothing but what is that state? That state is nothing but initial state. It's not reset. Reset means a zero. It's not reset state. Reset means it's not zero. It's an initial state. Okay. So initial state, here initial state means just overview, initial view, whatever the company logo or initial steps. Okay, ready to use your ATM, something, ready to insert your card, like that statements will be getting. Every ATM machine have its own specifications, all are not same, right? So that's what initial state. S0 will be initial state. Whole process. So what is the whole process of ATM machine here? We need to insert the card. After inserting the card, it will show some options. We need to select any of the option like withdrawal or pin change or address change or mobile number changing or deposit. We have several options. Initially we have language selection also based on that. After selecting your suppose if you want to withdraw some amount, after selecting the withdraw, it go to the next step, that to write the pin number. So we need to give our pin number. After giving the pin number, just ask for amount. We need to put that amount value there. After that, the transaction will be happen. Okay, so whole process, if you want to design by using the normal sequential logic circuit, how much time will it be taken? It takes lot of time. We need to use the registers to store the data, counter logic we need to use, ALUs we need to use, different types of logics we need to generate based on the output expression. Okay, but if you divide same thing in terms of state machine, say state machine is also complex, But once we understand the concept clearly, it is very easy to write the program. Okay, first of all, we need to understand the concept clearly, because mostly we will confuse in Mealy and Moore mission. So both have different rules, right? One is dependent on previous value, one is not dependent. And for Mealy mission, we need to write while transmitting the from state to next state, we need to write the output. But for Moore, we need to write within the state. So there will be some confusion or some rules. We need to follow particular rule. Once you know that, it will be very easy to write the final statement. Verilog code is very dead easy. Okay, but learning finite state mission is most complex task. Okay, you need to learn properly on FSM. Just you need to get the clarity how to design Mealy and Moore. Once you get the clarity, writing Verilog program is very easy. Okay, so whatever the steps I have said now, we will draw in the state mission overview. Just an overview I'm trying to give. So inserting the card. So first state 0, what will be happen? It's a reset state. Reset state means initial state. Why? Because suppose I'm just using this ATM mission as a user 1. After whenever it is completed, it should go to initial state again. It should not be in the same transaction history like that. It shouldn't show like that. It should go to initial state, right? So that's why always state 0 will be initial state, because if first one user is completed, then automatically it go to reset state or initial state. Then second user can use, and then third user, fourth user, like that. Okay, so S0 will be initial state, and next S1 will be the second state. Maybe in second state, what we can do here, we need to select any of the option. There will be lot of options. Suppose I'm selecting the withdraw option or pin change option. Okay, I will show you both. Withdraw option, if I select it in the state 1, it will go to the next state. State 2. In the state 2, it will ask for the pin number, right? So here I entered pin number. Okay, if the pin number is correct, it will go to the state 4, next state, if the pin number is correct. Okay, by mistake, if I enter wrong pin number, it will give some error here. Error. Again, it go to previous state or it go to the initial state here. That depends on totally your specification, how you are designing. Okay, like that state 4, if I entered correct pin, it go to the state 4. Okay, in state 4, it will be asking the amount. So how much you want to draw. So I'm entering that amount here. Okay, so after entering that amount, it will go to state 5. State 5. So whatever the amount I have entered here, if that amount is available in my account, okay, it will go to the state 5. Okay, if amount is not available, suppose if I given more amount, instead of, suppose in my account I have only 10,000, but I have given as a 20,000, but 20,000 is not available in my account. Okay, then also we will get the error. The amount is not available or transaction failed, like that error will be getting. So again, it will go to the previous state. From previous state, again we need to re-enter. If it have the re-enter option, it will go to the previous state. Okay, or else it go to the reset state. Okay, suppose whatever the amount I have given, it's correct, then it got to S5. Okay, next after S5, it should give the transaction, like it should done the transaction and need to give the amount, okay, at output. So S6, here in S6, if transaction is ready, we will receive the amount here. Okay. But sometimes in ATM also we'll get some error issues or server issues will be there, right? If any server issues will be there in S5, we will get notice that, or even S6. If server issues are not there, sometimes ATM also they doesn't have the amount, proper amount. Okay, that time also we'll get the transaction failed. Okay, so in that case, if transaction is failed or amount is not available in ATM machine, here also we will get the error. Go to reset state. If transaction is successful, we'll get the successful and we'll receive the amount. In that case also, next state will go to the initial state. Okay. So this entire process we divided into the number of states. Even traffic light controller also same. First reset state will be there, S0. From S0, S1. So which light should be glow, red or green? Next, S3. So mostly if you go to simple design, here red will glow, here yellow will glow, here green will glow. We will write what is the present state, what is the next state. Okay, like that vending machine will be there. You already know vending machine. Vending machine means we will same ATM machine, but in ATM we will just insert some card and we'll retrieve some data amount. Okay, but in vending machine we will buy something, right? So we'll just put that amount there. We need to select the grocery or whatever. For that it will take the payment. If any change is left, it will be given in the same wherever we put that amount in that like there will be some box. So from that only we'll get the amount. Vending machine also same, similar to the ATM machine. Okay, but few differences will be there. Even elevators, lift controller machine. Lift controller machine nowadays mostly we are getting automatic. So if you see mostly recently I have seen one like that is very automatic. How like just the digital the data how we will give. Okay, so like suppose I will explain clearly. There are 5 floors or even 20 floors also. Okay, so how the data will be taken for 5 floors? Suppose if you want to go for 4th floor, you are in 1st floor. Okay, 1st floor to 4th floor means whenever we are in 1st floor, whenever we click on 4, first plus 3 steps. So 1 plus second step plus third step plus 4, 3 steps. After plus 1 plus 1 plus 1, it will go to the 4th step. Okay, from same 4th step 4th to 1st, then it will decrement the value. Internally lot of coding will be there. We will write the program for elevator also tomorrow. We will discuss these type of things. We'll design the sequence detector. Okay, we will take I can take 2 sessions for final state mission. Actually 1 session only as per the schedule, but I can take 2 sessions for more clarity discussion because these are the most important topics. Once you know the final state mission clearly, then any project, in every project we use FSM protocols also. Whatever the protocols we are going to design, like UART, I2C, APBA, HBA, XI, or even projects, everywhere we use FSM. Without FSM, we can't design anything. Okay, so we will discuss more clearly for writing the program also. Okay, whatever I have said, just to go through the theory. If you go to the theory, you will get a more clarity so that while we are writing the program, you can understand very easily. Okay. So till here, everyone clear? Any doubts? Any doubts?
No, no, ma'am.
Okay. So what are the applications? What are the usage you already understood, and how the FSMs are drawn you already understood, and what are the applications? Most of the digital circuits we use finite state machines mostly in every design. Okay. Next, for ATM also you can try whenever you're free. Just try for ATM mission also. You can consider any of the circuit. See here, finite state mission. First start from here, start option. Enter card or verify pin in transaction 1 T1, or re-enter pin. That means what? First, after starting, after putting the card, after inserting the card, verify the pin. It just verify the pin. If pin is wrong, you need to re-enter again. Next, T3. T3, T2 is a re-enter the pin. T3 is a abort, like any error. It will go to the reset state like that. T4 pin verified. So next, after T4, here T5, T6, T7, T8, T9, T10 from state 2 to state 3, dispensing the amount. So in T5, just those all are substates. T1, T2 means those all are substates where we have the multiple options. T5 means get balance or display balance. T6 deposit or take money. T7 withdraw or dispense. T8, T9 take money. T10 display balance. Within the states we'll have those. And same here, this is for ATM mission. If you go to bank, here ideal, from ideal, first state is nothing but ideal or setup. We can call anything. Here we have verify the pin, and then card, here pin correct or attempts. Sometimes we'll have the number of attempts limitation also, 2 attempts or 3 attempts. Next, pin incorrect or attempts plus plus. Okay, so we can design any way. It totally depends on our functionality. If you want to design very simple, you can choose this whatever. This diagram is very simple. If you want to go with a complex thing, then you can draw your own finite state mission also. Okay. Next, what are the different models in FSM? We have only two models. One is a Mealy, one is a Moore. So what is the difference between Mealy mission and Moore mission? Mealy mission is whose output values are determined both by its current state and the current inputs. So here output is getting from first inputs x1 xn, or the main inputs, present inputs, here current state inputs, and also here another inputs, state memory. From the state memory, whatever the output is getting here connected to the output logic, and the same here the feedback is connected to the next state logic, present state feedback. Okay, so for main output, the main output is dependent on present output which is coming from the state memory, and also current inputs. Okay, depending on current input, or else we can tell present input, present state input, sorry, output, and also depending on the current input. Okay, and coming to the Moore mission, output will be dependent on only present state. Okay, whatever the value we got from present state, only that state output will be considered here. Okay, but we have a lot of differences between Mealy and Moore mission in terms of advantages or in terms of limitations. We can discuss both. Okay, see here. So output is depending on the present inputs and also current state here, and here only current state. Okay, here output is depending on two states, independent, sorry, dependent, both are dependent. Okay, suppose it's a sequence detector 1 0 double 1. 1 0 double 1 means what? State 0, state 1, state 2, state 3. So here we'll get 1. Can you tell me how many states are required for 1 0 double 1 in a Mealy, and how many states are required in Moore for 1 0 double 1 sequence detector?
Moore machine requires more number of states compared to the Mealy model.
For Mealy, how many states are required in this case?
Four states only.
Okay, for Mealy?
For Mealy, it's 4 states. For Moore, it will be 5 states.
Okay, okay, 4 states. So 1 is getting from S0, it's a reset state. So here it is passing 1. 1 means it will be taken 0 here, another state. Every state will pass two values, 0 and 1, right? Output. Here output will be 0 because it will not detect. For Mealy, we need to mention the output in the transition. And here 0 is transitioning here, and here also it will not detect the output, so 0. And here it is sending 1, here also it will not detect the output, 0. Okay, so this is what Mealy mission. But here S3 need to send to S4, but here we are not taking another state from S3 to S4. Why? Because suppose this 1 is the current state value here, 1. Okay, and it will be getting the previous value also. It will be dependent on previous value, current input also. What is the current input for this 0? 0 is the current input. And also here it is passing 0 and 1. What about 1? Here 1 will be having here only. Why? Because already 1 is getting from S0. So for S1, 1 will be here only itself. Okay, in S1. And coming to S2, here it is passing 1 to S3. What about 0? 0 means it will go to the reset state because already S0 is storing 0 value. So here in this case 1 by 0, here 0 by 0, and here S3, 1 is the value. Okay, and from S3 it should pass two values, either 0 or 1. To where it will pass? Mealy means 1 means it will be here 0 it is passing to here, already 1 is storing here, so it will be coming here 1 by 1 because last one is a 1. Here 1 means it is detecting the output. So current state value is a 1 here. Okay, So it will be dependent on current state value and also previous
Ma'am,
input. So yeah, tell.
I think S3 has to go for S0, right? Actually, to repeat the sequence 1011 1011, we need to send the S3 1 bit has to S0.
S not S not.
Yeah, starting initial S0.
Okay, but here S not will store only 0, right? 1 will be
0
passed.
only, but this is overlapping means we need to count
Overlapping
1011.
means we have both cases, overlapping and non-overlapping.
Yeah.
Overlapping means you can add anywhere, like even here also you can add 1011. Here also you can add, or here also you can add. We have two cases, overlapping and non-overlapping. Okay. And
Ma'am, I have one doubt.
mm,
So from S2, why is it going to S0 and not to S1? Even if it goes to S1 also, it can form a sequence, right? 1011. But why it has to go to S0?
here these sequences we can write anyway, like we need to get the proper flow 1011. Here I'm just showing how we can write the states. Okay, but particularly if you want to draw, we need to if you want to understand this, we need to draw the table. Based on the
Okay.
table we can pass which state is going to the which state. Okay,
Oh,
I will
okay.
go. Particularly we need to follow the table. I thought of explaining the table tomorrow. See, this table we need to draw. What is the present state? What is the next state? If you draw like this, you will get a very good clarity how to draw. Okay, today I'm just giving the
Okay.
all FSM. Tomorrow we will discuss these things. So here it will be detecting from this signal and also current state. Okay, so that's why we will have one less state comparatively more. Okay, so here S3 will be dependent on this signal and also this signal. If it is a 1, 1. And if it is a 0, 0 means mostly it will go to reset state. Even 0 also will get output as a 0 only. Okay, but coming to the Moore mission, S0 passing 1, S1 is passing 0, S2 5 number of states, S0 to S4. Okay, here because value will be dependent on only present state. It doesn't depend on before input. Okay, so in terms of area, if you see area wise it is efficient. It requires only 4 number of states comparatively. It requires 5 number of states. Area wise not efficient. Okay, but in terms of industry, which one is used mostly? In the sense Moore mission, even area wise not efficient, but still we use Moore mission. Why? Because we already discussed glitches concept, right? Glitches and hazards in the last week, I think so. Static 1 hazard, static 0 hazard, dynamic hazard, and glitches we have seen, when the glitches will be occurring, and also what are the ways we can avoid the glitches, like by using the flip-flop at the output side, or in corner map we need to take the redundant gates. Okay, so based on that we can avoid the glitches. So here in Mealy mission also we get the glitches. Why? Because these two inputs are not in synchronous, both are not dependent on clock signal. Maybe this input may get at some time, this current state value may get sometime, just a very minimal time difference will be there in terms of very milliseconds. Okay, but even that would be glitch means what? Without going the value like this constantly, like this, just sudden change will happen, like this sudden change, that is nothing but glitch. Why that sudden change will get? Suppose this output is getting at 5 seconds, this input, I mean this input is getting at 5 seconds, this input is updating at a 6th second. So this output, instead of going like this constantly 0, whatever this updated value is there at 6th second, just it will just go like this, whether it is a 0 or 1. Okay, so that is what we call as a glitch that would be occur in the Mealy mission. But in Moore mission, we don't find any glitches. Why? Because only one input will be getting for the output logic. Okay, clear everyone? Any doubts?
Prasanti, then the Mealy machine, this 1011, can you please repeat this states how it is, like from S0 to S3, how this 1011 got?
Okay, yeah, I will explain. So S0, S1, basically the sequence detector means 1011 S0 from state 0 to state 1. Initially it's the ideal state, reset state. So anyway, here state 0 to state 1, it is passing one value. So here reset value means what? Whenever it is a 0, it's the initial state, reset. And here from state 1 to S2, it is passing 0. For Mealy, we will write the outputs like this: 1 by 0, 0 by 0, and here also 0 by 0. And here one, next one is a 1. Here also it won't detect the output, because whenever it get total 1011, at this case only output will be detected. So there only we'll get as a 1. Okay. For Mealy mission, we have one bit less. Yeah, tell.
So one oblique, like for example, here in S0 to S1, there is a 1/0. So one is the present state, I mean, what it shows, or I mean, 1/0, what it shows. One is which state and 0 is which state?
1 is a present state. 0 is the output.
Okay.
Present state value, transition value, the sequence transition, and 0 is the output here. For Moore, if you consider it as a Moore, for Moore we will write within the state by 0, by 0, by 0, by 0. For last state S4, it will detect the sequence here 1. So 1, 0, 1, 1. So here we'll write as a 1 output in the state itself. But here for Mealy mission, we will write like this. In transition side, we'll write the outputs like this. Okay, so here Mealy is dependent on both the present state and also input. Okay, so this state is passing 0 to here. Every state will pass 0 and 1. So S0 will pass 0, 1. 0 is storing internally into this state. 1 is passing to S1. S1 passing 0 to S2. So where it should store that S1, where it should pass that S1. Here we don't have any case, like we can't send to the S0 because S0 already storing 0. So here S1 itself stored the 1 value. Why? Because already it having 1. Okay. And coming to S2. S2 have S2 is passing 1 here according to the sequence. Then what about 0? So it can go to here 0. Whether suppose in case 0, 1, 0, 1, 0, 0. It can detect the sequences. Anyway, it's a reset state, right? Reset means initially it will start from this 1 onwards. Okay, even it go to 0 here, that's not a problem. 0 by output is also 0. Okay, next coming to S3. S3 also, here, this is for melee, I mean Moore. Coming to S3, 1 is getting here, but another 1, where it should get another 1 to detect this 1 value. Means this is what present state. Okay, it will be having input also, where it will get the input to this current state. This current state will generate 2 inputs, right? One is one value, 0 value. 1 value, 0 value. So where we need to send this 1 value and 0 value based on the
1
sequence
to
detect.
1 to S1.
1 to S1. Okay. And
0
0
to
to
S2.
reset.
S2. Okay. S2 is also fine, no? No.
S2 is also fine, or reset also fine.
Okay.
Here,
Yeah.
if we write 1, here it will be detect the sequence here. So current state and this value, both are getting from the input sequence, it is detecting the value, not on the current state. But for melee, here we'll get 0. Suppose for Moore, if I am taking here as a Moore, it doesn't depend on its input. It doesn't depend on the input. It just depends on the current state value. So whenever we get 1 here, then only it will be detected the output here, 1 for Moore. Okay.
Yeah. Prasanthi.
Clear? If you write the table like this, you will get more clarity. No need to confuse which state will go. Suppose a same example if I am considering here. A circuit to detect 3 or more number of ones in a serial bit stream. It will detect 3 or more number of ones consecutively. If there are 3 number of ones consecutively, like 111, 0, 1, 1, 1, 1, 1, 0, 0, 0, 1, like this. So here it is detecting 3 number of ones. So at this point of time, we'll get the output. And here it is detecting 3 more than 3 number of ones. So at this time, we'll get the output as a 1. Remaining all cases, we'll get output as a 0. So how we write the finite state machine for this? Okay. So we should not draw finite state machine directly. First of all, we need to write the table, state table like this, and also diagram. So so initially it's a reset state 1. When reset is high, we don't get any output. Okay. So initially it's a A. If reset is high, A is a initial state and output will be 0. If reset is 0, then only we'll get the output. Okay. So current state is 0. The bits are applied serially in synchronism with a clock. The output will become 1 whenever it detects 3 or more number of consecutive ones in the stream. So we will write 1 0 triple 1 double 0 4 0, I mean 4 1 double 0. Okay, so here initially state is 0. I'm not drawing for this. I'm just explaining for this. Okay, present state is A. Then what is the input? Input is 0. Then next state is A. Output is 0. For A, it will pass two values 0, 1. B also having two number of input values 0, 1. C also having two number of values 0, 1. And D also having two number of values 0, 1. Okay. Based on your sequence, which value should go front and which value should go back. That means states it will be detected. Okay, so from here this table also we need to from this table we need to draw the circuit diagram, FSM diagram. So currently A, 0 means A only, next state also A only. So currently in A, 0 means A only. From A, input 1, then what is the next state? B. B for input 1. Then what is the output? Output is 0. Next, for B, for 0 value, if input is 0, then what is the next state? Next state is A. So this value, A by 0 by 0. For B, if input is 1, then what is the next state? C. So here 1 is detecting, if you observe, 1 is detecting, second one is detecting here. Okay, next B1 means C, B 0, okay, C0 means A, C0 means A, this one. Here also not detecting the sequence because input is 0, so output will also 0. Here also not detecting the sequence because even it's a 1 but only single one. Here second one, but in question minimum 3 ones or more than 3 ones. Okay, so next C, if input is 1, then it go to D. So here D. Okay, 0 means it is going to A, output will be 0. 1 means it is going to D, value is 1 by 1. Why we got the 1 here? Because 3 ones are detecting here. In this case, here 1 we got, here 1 we got, here 1 we got. So 3 ones. Next, D, 4 states. 0 means A. Here output we got 1 because here it is detecting, and for D, A input value is A, so it is going to A, output is 0 for 0 transition, and input value is 1, output will be in D only. Why? Because already it is passing 0 to here and D will be here 1 by 1. Here also it is detecting 1, 1, 4 ones. Now at fourth one also we got output as a 1. Okay, like this you need to write the truth table, state table, and draw the diagram, state diagram. So for this logic, if you want to draw the diagram, same, this diagram will be applicable for this also. How you want to check that thing means, you can give the input value, this input value, the same sequencer. Take the screenshot. Tomorrow I will tell you how to write the program for state diagram sequence detector. Take this same screenshot and tomorrow we'll write the program for this and check the output, whether you will get exactly this or not. Okay. Is it clear, everyone? Any doubts? Any confusion?
This is clear. So one thing, Prasanti, this after getting 3 ones in the D state, we got output 1, and then for 0 0 we came again for A state, and the 4 ones are there, no, here after that.
Mm.
After that, so this again will
This
go.
it will be detected here. 4 ones.
Okay, 4 ones.
Again, it will go to from starting.
Yeah. Okay. Yeah.
Everything will be checked from the starting initial value only.
Mhm.
Whole state mission. It will be run with whole final state mission. It will check initially 1. So here initially 1 by 0. And then 0. If it is a 0, it will go to state here. If it is 1, it will go to state here. Okay, again suppose here 1 is there. Here if it is, suppose in case in this case, suppose it is 1 1 1 we have written. So 1 1 1 means what? Here 1 is detecting, this state will continue like this and it will continue like this. So we will get 1 as a output at this point of time if these 3 are ones. But here we got 3 as a here 0 we got, right? So 0 means what? This state will go like this and here we'll get as a 0 as output. So here sequence 111 is not generating. So here also we'll get as a 0. And again double one. Double one means again the sequence will be started like this, and even double one means we don't get here. It will be started here and we'll get as a 0 output. Again double 0 will get output. Here triple one. Triple one means it will be detected like this. Here, here, here. So we'll get as a 1 at the output. Again here also 1 is there, right? So it will be sequenced like this. So here also we'll get as a 1 output. But if we return as a 0 in this case, not 1, 0 in this case, then what will be there? It will go the sequence like this and this 0 will be printed here. Okay. Clear?
I have one doubt.
Okay.
I mean, I got confused here. So, from so on a 1, it goes from A to B, and then
Okay.
on 0, it's going from B to A. So on the next one, from where will it start? Will it start from state A or B?
From here itself only it will be started.
Okay, okay.
It will just detecting. Detecting means what? Continuously it will check whether 111 is available or not, 4 ones are available or not. Every state it will be checking. Every state will be start from initial only. This 1 will start from initially, this 0 will start from initially, here also it will start from initially, here also it will be started initially. Everything will be started initially, but sequence is available, then it will be detected. The loop will be rotated like this.
Okay, got it. Thank you.
Next, others, any doubts? Okay. So tomorrow we'll see the program for this. And next example. So in sequence detectors, we have overlapping and non-overlapping also. Once go through the differences between Mealy and Moore. Mealy, Moore output depends on both input and current state. And here next state is dependent on both input and current. Asynchronous glitches will occur. Less number of state, more efficient, area-wise efficient. But for Moore, outputs are synchronous, no glitches, more number of states, obviously more number of flip-flops. Okay. Next sequence detector example 110. So how the sequence will be detected for 110? Will you try for this example 110? Already here Moore mission, Mealy mission is written. Moore mission. S0 means initial state here. 110, right? So here 0 is passing, and here 1, and here 1. 110. So whenever it is detecting here 110, here we got the output 011 backside from backside. If we write the truth table like this, first 0 is detecting, then 10 is detecting, then 110 is detecting. So in that case, from this truth table, we'll get the circuit diagram like this. If you want to write reverse, you can write like that also. Whatever the state mission you are writing, it should detect that sequence, whether it is detecting that or not. That is our final output. And here Mealy mission. By using Mealy mission, only 3 states are enough. Why? Because here it is depending on current state and also this input. Okay. And overlapping, non-overlapping. What is the difference between overlapping and non-overlapping? Suppose here, let's consider a sequence recognizer which is capable of detecting 1001. 1001 means, suppose if you see here 2, 3, 4, 5. Here 1001 is detecting, output is 1 for overlapping and also non-overlapping. And here 5, 6, 7, 8. Here also it is detecting, output is 1. And here 1 not detecting, and here also 1001. Here also it is detecting, overlapping and non-overlapping. So if you see here, for overlapping it is detecting 1001. Overlapping means what? Whatever the before value is there. One, 1. This 1 is also overlap to this 1001. For non-overlapping case, we got the 1 here as an output, but here we didn't got the output as a 1 because it's a non-overlapping. But for overlap case, here we got 1, here also we got 1. Okay. In diagram, state diagram also, we can draw in both different ways. Okay. Same, see here, for Moore mission. First one is a overlapping. Overlapping means what? One, 1. Where it is overlapping here at 5th, this 1 is overlap here. So 1 is writing from here. Even it is not getting this one will be overlap from 1001. Before some of you told for meal emission, first example, whatever I discussed, some of you, one boy told we can also put in the middle, right? So you can put them in the middle also. Whenever you want to overlap the case, you can put in the middle, okay? Or else you can put to the reset state, initial state, okay? So if you observe here, 1 here and 0 reset state. And here also non-overlapping. Here it's a overlapping. Okay, clear everyone? Have you gone through these examples and any reference videos? Tomorrow I will share you the FSM assignment, so you will get clarity. Till now, I have given the assignments on flip-flops, registers, counters. So everyone tried for Verilog in counters, like designing the up counter, down counter, multiples of 3, skip the multiples of 3, mask multiples of 3, and also sequences 1 time, 2 times, 3 times. Have you tried all these things? We got some gap also this week.
I've tried some of the assignments, like Verilog 1 and 1 and 2 assignment. Now, and problem solving assignments I have also done. But some doubts are there, not reached to the counter assignment yet.
Have you gone through these assignments also? Digital interview questions, one of the best assignments. So whenever you got some time, practice daily at least 2 to 3 questions. And in Verilog also, I have updated some assignments. Without these assignments, I have shared assignment from each topic, from combinational and sequential. And these assignments are different. Whatever I shared, those and these both are different. So whenever you get time, then try to practice this. Okay, very important. Verilog book also for reference. And only interview questions in this. Are you all able to access this? Still anyone there without access? These are best interview questions for Verilog. If you revise all these things, mostly you will get 90% of Verilog from this. All these are mostly discussed. Basic Verilog task and functions, so we need to discuss because mostly it is related to system Verilog topic. And parameters we already discussed. Here you will have more detail like a def param, spec param. These are not required, but once you can just have a look, okay, for just interview point of view. And ports we already discussed. Assignments here, task and function storage elements discussed, flow control constructs discussed, final state machines will discuss, memories also, and general design considerations like path, setting the path, RTL design practices we already discussed, multiple clock design considerations. We already discussed the generating of clock, and FIFO we will discuss in the next session. Coding techniques with the area minimization, like if def, if and def. These all not required, but if you want to learn more advanced, you can learn. Static timing analysis we need to discuss. DFT also there, design for testability. So whenever you have some time, these all are we discussed. Behavioral model monitors, random stimulus generation, gate level simulation, all these things all discussed. Miscellaneous also just interview purpose. All these operators also we already discussed. Forever, repeat, while, for, do, while. assign, deassign, force release. This one we'll discuss in the protocol. You will get there, deassign and force release. So just have a look, and you can avoid this Verilog topics. And these also best assignments. This, okay. So tomorrow we will discuss more clearly on FSM and writing the program. Still, anyone there to practice some questions? Please go through that and practice. Here already FSM questions also available in digital logic design, whatever the assignments I have shared. If you go to last, you will find a lot of interview questions regarding FSMC. How to draw FSM. Practice this. These will be enough. Okay. There are a lot of models here. There are a lot of questions. Try to practice. Okay, any doubts? Manoj Kumar, Tarun. Okay, so take time today and tomorrow. By coming by next session, everyone practice those digital logic design questions. Okay, don't put any pending works because we are going to complete Verilog by this week mostly. From next week, we are starting system Verilog. Okay, so these assignments and that assignments, don't put any pending works. Okay, so that's it for today.
Prasanti, after completing Verilog, can we have doubt sessions for assignments?
Yes, for Verilog, we have the doubt sessions and also static timing analysis going to start from 15th, March 15th. So you can join for the STA sessions also. And we'll have mock for Verilog, mostly on next Sunday. Next Sunday, we'll have one-on-one mock for Verilog just to understand your like how much you have learned till now. So we will get some clarity and we'll give the feedback. Okay, overall Verilog HDL. So everyone try to practice by next Sunday. Okay, both theory and lab. Vinita, do you have any doubts regarding assignment?
Yeah, in Verilog second assignment, I have a doubt. I have done the problem solving. That was the mostly problem solving ones. So I
Okay.
have a doubt, one or two doubts in that.
Can you share your screen?
Yeah, my screen, actually, I'm joining from mobile. Here it
Okay.
is not there. Yeah.
Okay, then just put in the group once. I will check what is the
Okay.
problem. Okay.
Overflow detection, in that I have that signed ones.
Overflow detection. Okay.
Addition of overflow detection I have done. There were 2-3 questions of overflow detection actually. So that so in that I have doubt. And in the problem solving, they were most of the time I have done. Now I'm coming to the sequential and counters. Then I'll let you know.
Verilog assignment 1.
2 Verilog assignment 2. This one. Yeah, that one is.
In this?
Yes. Yeah, one is this barrel shifter. Barrel shifter, what is that? I mean, I need to
Barrel
understand this barrel
shifter.
shifter.
It's a
Question number
shift
3.
register. It's a shift register. You need to understand the logic. You are designing a 4-bit adder or subtractor that can perform both addition and control signal. Additionally, you must have overflow conditions properly and report the result.
And some
Here,
yeah,
overflow in the sense just carry. Suppose if you do 3 plus 6, 3 and 6 will be in the one range, like 3-bit range. But
yeah,
3
for
plus
addition I have done, like for subtraction I got the confusion.
okay. For subtraction, if you don't get a overflow, just avoid that. Mostly for addition only we get overflow.
Okay.
For subtraction, we don't get overflow. Underflow we will get.
Yeah, underflow.
You can
And there is a Booth algorithm in the 5th question. There is this one. That
fifth
is
one, Booth multiplier also it's a complex thing. Booth's multiplier actually it's separate project kind of thing. Booth multiplier and this barrel shifter. If you are able to do, try, or else I can assign you another mentor.
yeah. I mean, another mentor is also fine for doubt discussion. That is also fine for me.
Okay, okay,
Yeah,
fine.
for doubt discussion. Yeah.
Okay. Here also valid strip multiplier also very complex thing.
Yeah, these
Internship
things. I mean,
project we are doing.
actually, that I didn't know these. That's why I have not done these things. Apart from that, there is like below there are so many problem solving, some interesting problem solving are there.
Mm,
Those
mm,
I have done, but these which I don't know those algorithms and all, so that I've
mm.
done.
Okay. So for better practice, can I share a simple simple assignments or else like this? Just a design a decoder, priority encoders, these type of
That is
assignments.
there in the Verilog assignment one, like designing a priority encoder and
Okay.
those things are there in like that is fine. I mean, just that
Okay.
the algorithms we don't know. I think that's why.
Mm.
Like
Yeah.
if you see in
All
the
are
down,
advanced.
that is
Mm.
in the down the questions are nice. Like in this we have a. I mean, whatever we
You can
read.
try this
Yes,
after
yes.
revision.
So like yes. After this, it is. I mean, just we need to connect whatever we have read. Yeah,
Okay. Okay.
that.
These all are
In that
FS related.
actual in that fourth question, we can do like up and down counter, like a control signal for 0, we need to do adder, and for 1, we do subtractor using if-else statement.
You can do both parallel adder or subtractor. You can write using behavioral or
Then carry
structure.
bit we can store in the overflow, and we can
Yes.
just print the
Yes.
overflow in test
Carry.
bench.
If carry is getting 1, then it is a overflow. If carry is getting 0, then no, nothing. Underflow also you can detect for subtractor.
Yeah. For adder, actually, overflow is also there in the question number 2nd. That I've done, but not that is
Okay.
done. The digital calculator that
Hmm.
is having for the 2-bit it is there.
Okay. Okay. Others? Any doubts? Lahari?
No, ma'am.
Roshini? Tarun? Manoj Kumar? Okay,
No,
fine.
ma'am, not.
And practice final state missions. Okay. Okay, then thank you all.
Thank you, ma'am.
Yeah, bye.
Thank you.